Welcome everyone to the 31st episode of our Project AstroMiner DevVenture. So there were some problems by the end of our last live stream, the last episode, and I wanted to fix them, but we ran out of time. So I kind of forgot where I was. I want to pick up where I left off last time. So let me try and just get my bearings, and then we can move on swiftly. So I noticed we got some output errors. What is it saying? Too few arguments in destroy. Aha, here we go. So this is where we were. We were trying to fix, if I remember correctly, it was to fix the destroy and the shoot and all of those things connected, right? So that when something is destroyed, it knows who destroyed it and how. And to do that, we kind of had to fix some of the fundamentals. And I think you're kind of picking up a pattern here, right? Like we keep going back to the foundations. That's why we can't build yet. Because if you keep building and then you go back to the foundations, everything collapses and you have to start again anyway. And all that effort goes to waste. So let's try and fix the foundations and then see what's left of the foundations before we build up, right? So like I said, we're working according to a layered development system, or what I like to call the Shreknique, right? Or the onion methodology, whatever you want to call it. So if I click on one of these error messages here, why can't I go to it? Anyway, we see here in behavior target on line 57. So behavior target, line 57, there we go. The destroy function takes in a shooter type and a shooter ID. Okay. Now here we've got the shooter type and the shooter ID. So let's just pass that in. So we'll say shooter type and shooter ID. All done. That error is addressed. All right. Then we've got another error over in component behavior script, behavior target.gd. Pause error. Seems happy now. All right. So you call destroy with the shooter type and the shooter ID, and then it emits a signal with the shooter type and the shooter ID. But there is a signal that's connected in host node .connect. The host node's on destroy target. And where is host node? Yeah, host node get parent. So this would be in the waypoint class. So we need to go back to the waypoint behavior waypoint, and search the on target destroyed function that is connected to the target destroyed signal, and make sure it's accepting those two variables and using them correctly. So let's do that. Go to behavior waypoint. We go to on target destroyed. We've got the shooter type and the shooter ID, and we are not establishing that. So this is line 45. So we'll put the assignment operator on line 45, and we'll say the shooter ID is the destroyer ID takes on the value of the shooter ID, and then the shooter type, right, is waypoint destroyed is the signal, and up here waypoint destroyed is being connected into the enemy ship controllers on enemy destroyed waypoint. So as you can see, there's quite a lot of indirection, as I call it. In C++, there's this thing called pointer indirection. You don't have to worry about that. But it's basically referring to if you've got a whole lot of things linked together. Okay, this is a digression, I understand, but it's just so that you can keep track of the things that I say, right? So here we go. Just that's the wrong window. Always apply the settings properly and then use the pen. Okay, so if you have, what I mean by indirection anyway is I've got this class here. Again, let's use boxes or circles. Let's use circles, ellipses, right? And change the color depending on the class, right? So this is the primary class. I'm going to keep things general and not specific, just because this applies in everything, right? It doesn't necessarily apply just for this one thing. And then we change the color to some blue color. That's way too blue. It's going to come out too dark on the black background. So we'll use a lighter blue like this. Okay. And we've got a red color. Some reddish color that's a bit, well, that's fine. We'll just use normal red. Okay. And then maybe a green one as well. Okay. So we've got these. We'll change the color to like yellow now, just to have a distinction in the arrows, right? So now we've got these links, right? So this one references something here. Okay. But then because it's referencing something in the green thing has to reference something in the blue thing. And then the blue thing has to reference something in the red thing. And then the red thing has to reference something back in the white thing. So you can kind of see how instead of just having this direct communication between red and white, you have to go through green, blue, and then red just to get the change that you're looking for. Okay, this is referred to as indirection or dependency. And, you know, in some cases, it's unnecessary. In some cases, it's healthy. In other cases, it's unhealthy. In some cases, it's unnecessary. And in some cases, it is necessary, right? And as a good practice, I think in this case, it is actually necessary because you've got this, security layers, right? So you can't just directly change things. You have to go through intermediate steps, and that might be inefficient. In the, you know, on the surface, it looks inefficient, but for the security that you gain and the stability in your infrastructure, it actually makes more sense to just do it this way rather than to have a direct access to the data. I'm talking very abstractly. I appreciate that, but I do think that in this case it is required. So, and again, remember the reason for that, as I mentioned, is we are dealing with layers. Okay, so that's probably that probably explains it a little bit better, right? Is that we've got these layers, and so the enemy ship controller, which is the white layer, is dealing with a behavior manager, which is the green layer, and then it's got some entity, which is the blue layer, that has these behaviors, right? So it's dealing with or actually the entity is the green layer. So it's the enemy ship controller controls the enemy, right? And that enemy has an NPC behavior manager, which has behaviors. And in order to affect the behavior as the enemy ship controller, it has to go this way, because the enemy ship controller doesn't care which behavior is being called. It only cares that the pattern it wants is being executed, right? Remember that. So it's like, I want this pattern, so do this pattern. And then the NPC behavior manager is like, okay, well, how am I going to do it? The enemy ship controller goes, I don't care, that's not my problem. I just want the pattern done. And then the NPC behavior goes, okay, fine, I'll figure it out. And then it says, okay, well, I'm over here, and my allies are over there, and I am the best fit for this particular role in the pattern, and so I will call this behavior. And then it's like, hey, you behavior, let's do this. And the behavior goes, okay, cool. And it goes, I know exactly what to do. I have a script. Let's do it. It runs the script, lets the behavior manager know, hey, I've done this thing. What next? Then the behavior manager decides if the pattern is complete or not. And if it's not complete, it's like, okay, now you need to do this behavior. And then it's like, okay, that's done. Okay, now you need to do this one. Okay, that's done. And so on until it's done. And then it's like, hey, enemy ship controller, the pattern, my role in the pattern anyway, has been complete. My role in the pattern is done. And then the enemy ship controller decides, is the pattern complete or not? Right? Because if he's completed his role, that doesn't necessarily mean that the others have completed their roles. And so once everybody has completed their roles in the pattern, or if the pattern is no longer relevant and there's a new pattern that requires attention, it will then let all the relevant enemy NPC behavior managers know that, hey, there's a new pattern, start doing your thing. Okay, so that's the reason for the indirection. And I hope that this has been clear, right? That this indirection is required based on the fundamental architecture of the system. So coming back to this, we were jumping around a bit, and now I think you can appreciate why, right? And that's the reason why I went into Krita and drew that little diagram, is to explain why I'm jumping around in the scripts so much. And that it is actually important to come back to a diagram like this, just so that you don't start drowning in, in the details of the script, because it's so easy to get lost and go like, oh no, what is the point of all of this? But you have to keep your eye on the high level or the big picture and see, like, just like if you're trying to navigate through a forest that you've never walked through before, you need to know roughly every now and then, according to the big map of the forest, where am I, right? So if I'm walking on a path and I know which path I'm walking on, and I come to an intersection with another path, I can check on the map where that is in terms of the actual huge total forest and say, oh, I'm over here in the forest, I want to be over there in the forest, and the current path I'm walking down doesn't go that way, and so now that I've reached this intersection, it makes sense for me to take a right turn, for example, and not the left turn, and not carry on going straight. Or perhaps I've been going the wrong way and I need to turn back, so there's that whole thing, and you keep track of the big picture so that you don't get lost in the details, or in this analogy in the forest, right? So now we're dealing with a specific tree, but we do need to know where in the forest we actually are. And in the on enemy destroyed waypoint, we need to go back and make sure that everything is being handled correctly, right? So let's just go back one step. Waypoint destroyed is a signal. And this signal is taking in an enemy ship ID and a waypoint ID. Okay, so basically it's saying a waypoint has been destroyed by this enemy, and this is the waypoint that was destroyed. Who destroyed it and what was destroyed? And then also we kind of have to know the shooter type, right? So let's change this from enemy ship ID to destroyer ID. Destroyer ID and a destroyer type. So we'll take in a third value called the destroyer underscore type. And this is a string. Okay. So we're taking in a string for the destroyer type. We're taking in an integer for the destroyer ID, and we are taking in an integer for the waypoint ID. So what type destroyed this waypoint? What is the ID of that type, right? So is it an enemy? Or rather, in an example, it would be an enemy destroyed this waypoint. It was this specific enemy, and this is the specific waypoint that was destroyed. Okay? And so now if we go back down here, we've got the destroyer ID, the ID, and the destroyer type. And so now let's just do this. I don't think we even need this variable, honestly. Let's just do away with it. And then just say, that's the shooter ID. So let's change this to be destroyer ID. And change this to be destroyer type. Then we'll say destroyer ID over there and destroyer type over there. Destroyed by destroyer type space, well, space or number. Waypoint destroyed by enemy ship. Waypoint destroyed by type enemy ship number 0, for example, right? And then waypoint destroyed by destroyer type, then destroyer ID, and then the ID. So there we've got our signal being emitted correctly with all the parameters. Here we've got our signal being initialized or declared with all the parameters. Here we've got the waypoint being connected, which doesn't require any of the parameters. And over here in the enemy ship controller, we now need to go and make sure that this has all the parameters. Okay, so we need to go enemy ship type string, like that. Okay, and so we're saying enemy destroyed a waypoint with waypoint ID, right? But we did this in the waypoint function, didn't we? We're saying target destroyed, waypoint destroyed by destroyer type number, destroyer ID. We've already printed this out, so we don't need to print this out here. This is unnecessary. We'll keep it because we want to debug things, but we also don't want to print unnecessary print statements all the time. So we'll just keep it and keep it commented out. Okay. And we kind of, because we're taking in an enemy ship type, right? We should actually rename this to be destroyer type, because it makes more sense to call it destroyer type and destroyer ID. And you'll find out in a second why that is, right? Because what I want to do is make this as generic as possible. So we want to say on waypoint destroyed instead of on enemy destroyed waypoint, because that's too specific. We want it to be as general as possible. Remember that this isn't necessarily just for enemies. It could be that we make the asteroids waypoints. We could do that, right? An asteroid could be a waypoint. And if the ally is a mining vessel that's an NPC, it's not an enemy, and it could also have destroyed the waypoint because it mined the asteroid to depletion, and the asteroid breaks up into a cloud of dust, right? And so now we need to know exactly who destroyed the waypoint. And if a specific kind of entity destroys the waypoint, that's the destroyer type, then we might need to do a specific set of behaviors in accordance to that, right? So That's where the destroyer type comes in. We're going to have a match statement saying if the destroyer type is type enemy ship, maybe make the target have an explosion animation with like a fire cloud and a shockwave and that kind of stuff, or and print out a specific print message, update the score, do all kinds of stuff. And if it was a mining vessel, we need to update the score, update the amount of resources available on that particular mining vessel, make a print statement, and break the asteroid up into the particles of dust, deactivate the waypoint as a mineable object, remove it from the mining objects group, and then so on and so on and so on, right? And then you're kind of getting the idea, right? That we want to be able to do different things depending on who destroyed this waypoint. So we'll change the name to on waypoint destroyed, and then we'll just have to change the name where we're connecting the function before we do anything else. So on waypoint underscore destroyed. Okay, then we copy this name. We go back to waypoint behavior on the top and connect it here. Waypoint destroyed to on waypoint destroyed over there. Okay, now that's done. So now we haven't made that mistake by forgetting about that change. We can go back into this and do a quick check. So now we can say match destroyer type and then all of this will be underneath type enemy ship, and then all of this will be for the enemy ship type. Okay, and then the underscore case for so we could have done this by keeping track of the group, right? So if the destroyer comes from the enemy ships group or the pirates group or whatever, right? So if we go to the groups tab here, we can see we've got these groups, right? So if it was a type enemy ship, if it was a group, it was part of the enemy ships group, then we could have done that as well, right? Or if it was a mining object, or if it was a target or a waypoint or whatever. But the way we did it is fine. We don't have to worry about that either. So if I go into the enemy ship controller again, now you see we've got the first type is type enemy ship. The second type is type mining vessel. I don't think we have a script for a mining vessel specifically, do we? We have behavior, enemy ship behavior, and player behavior, NPC behavior manager, enemy ship type. So we do have to use the grouping. Let me just see something. If I go to my, I've got scenes, I've got components. If I go to entities, the miner player. This is a type player, and it's the mining vessel. Okay. No, this is the player controller. Okay, okay. So where's the mining vessel? The mining vessel has the player controller, and then it's got an asset called the grinder barrel. So fine. I suppose we'll have to use groups. And then, so if you aren't following, it's because I'm making a decision right now without actually communicating it. So let me do that. In the enemy ship controller, we don't want the destroyer type. We want the destroyer group instead, right? So let's change that variable type to be type group instead, and change the match statement. So we'll just take that out. We'll take that and that out, and then we'll just unindent this. Okay, so the next thing we do, we still have some time. It's about 26 minutes in. And okay, I want to change this to be destroyer group instead. All right. And what I'm going to do now is the mining vessel should be part of its own group, right? So I'm going to create a group, and I'm going to call it, it's a global group, I'm going to call it mining vessel. This is the group for all mining vessel, for all type mining vessel entities. Okay. So I've just had an idea, and I'm gonna write it down so I don't forget. Okay? And I'm gonna explain it to you as I write it down so that you also can understand what I'm trying to do and can remind me if I forget, or so that it's on record, I can then go back and check the live stream to make sure I understood exactly what I said. Okay, so here's the thing. What I want to do for the mining vessel specifically, and I understand I'm jumping around a little bit, but just bear with me on this. Here we go. I'm going to zoom in here and maybe write it a bit down here. Just there, so we can kind of see where we are without get our bearings. Move this across. Just like that, so we know that that's the margin and that's the upper limit, so we don't get lost. And then I'm going to change my pen to white, and I'll start to write. Okay, now we want to make sure that we have an ellipse for the player, something like this, right? And we'll say this is the player. So if I zoom in, like that, now I can say the player controller. Notice how I'm actually getting better at doing single stroke characters. So this is the player controller, and it's a component. We want it to be a component. We don't want it to be the root class. Okay? We don't want it to be the uppermost class of the hierarchy. It shouldn't be on top here, and then it has all the stuff indented from it, like, you know, as a subset or a child of the player. The player should be a component, and we kind of succeeded at that. Remember that the player controller is literally just the first person controls with the first person camera. All right, so what I want to do is separate the player and make it a component, so that at the start of a scene we can decide if the player has selected the mining vessel or has decided to play in the mining vessel mode. Then we can simply assign the mining vessel. We can assign the player controller to the mining vessel scene, right? So we can give it that, almost like a resource, but it's not quite a resource. We just assign the node to the mining vessel, or even better, we have the mining vessel has the player controller attached to it, but only enables it once the mining vessel is part of the group of, of part of the player group. And then we can have controls in place, sentinels or gatekeepers, as I mentioned before, that checks if the mining vessel is in the group players, then allow this functionality to happen. Unfortunately, that's an additional check. Every time you want to move the mouse to change your camera view, it's going to do that check. So it's an additional computation that's happening all the time. And what would be better is just to assign the node as a component to the mining vessel at runtime. So let's just check with DeepSeek if that's possible. But what I first want to do first, I want to write this down so you guys are following. I really don't want to confuse you. Please do let me know in the chat if you are able to follow along with what I'm saying. If I'm jumping around too much, let me know, because I do want to make sure that you guys are following. Okay? And so there's the player controller, and what we want to do is we want to say yellow, because yellow is kind of the designated color of the mining vessel right now. And so the mining vessel is this rectangular box, and it's got kind of like these lines or slots in it, so it's got a slot like that, and a slot like that, and a slot like this, and so on. Right? So now what we want to say is that this is the mining vessel. So let's say that. Okay. Mining vessel. I still haven't found a way to dot the I without adding a second stroke. If there's a way that you can think of to make an I that looks like an I without a dot, I would appreciate that. If you could let me know. But for now, we'll just have to dot the I's. Mining vessel. All right. And if I zoom out, that kind of looks like a vessel, but I'll just change it again. A single pixel, just color that one in and erase these ones here, like so. Oh, that's better. Nice and clean. I like that. Unfortunately, we don't have a lot of time for this, so I should have left this for after the lesson so that we can appreciate the clean letters in the next session. But as you can see, that's a lot easier to read now. Anyway, we'll change the pen back to 3. And so now we've got this mining vessel. And what we want to do is we want to add to the mining vessel a player controller. Right? So we'll say add the player controller into the mining vessel like this. And we'll make a caveat. We'll say if and only if. And I'm sure you know that the if with 2 F's is shorthand for if and only if, right? So if we say if like this and only if, then if and only if player chose mine mode. Chose to be a miner. So if and only if the player chose to be a miner, add the player controller to the mining vessel. Okay, now that you understand what I want to do, let's see if it's possible to do. And if it's not possible to do, what is possible instead, right? So let's go to DeepSeek and make sure we can actually do this. So what I want to do is I want to change the mining vessel scene to be more modular. I want to add, or rather I want to make the player controller a component instead of an entity. And add this component to any of the ship scenes at runtime depending on the level settings i.e. player choose, or rather e.g. player chooses mining mode. Oh, that's chooses. Player chooses mining mode, therefore add the player controller to the mining vessel as a component node. Ignore the details of this implementation for now and tell me if it is possible to add a component to add a node as a child of another node in a host scene. For example, in the test flight.tscn level, we add the player controller node to the defender ship node i.e.scene instance as a child of the defender ship scene instance. Can we do this? If not, what can we do instead? Okay, so let's just read this out one more time so that it's not so fragmented and slow paced, right? So I want to change the mining vessel scene to be more modular. I want to make the player controller a component instead of an entity and add this component to any of the ship scenes at runtime, depending on the level settings. Okay, so player chooses mining mode, therefore the player controller player chooses mining mode, therefore add the player controller to the mining vessel as a component node. Ignore the details of this implementation for now, and tell me if it's possible to add a node as a child of another node in a host scene. For example, in the test flight scene level, we add the player controller node to the defender ship node, i.e. an instance of the ship node scene, and then as a child, we add that as a child of the defender ship scene instance. Can we do this? If not, what can we do instead? Yes, you can absolutely add nodes as children to other nodes at runtime. Amazing. This is a common and powerful pattern in Godot. So, in the ready function, variable defender ship gets the defender ship, and then the player controller is a preload of a packed scene. And then what we do is we say defender ship.add ship player controller as a child, if and only if blah 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 blah, right? And then you can also add specific positions in the hierarchy. So defender ship.add child player controller.owner is defender ship. This is optional for scene persistence. Oh, that's cool. And then insert at a specific index. Defendership.add child player controller, defendership.move child player controller to 0. This moves it to the first position. And remove later if needed. Defendership.remove child player controller, player controller.queue free. Okay. your modular approach is perfectly feasible. And here's the example that it wants to give us. This approach gives you exactly the modularity you want, dynamically composing ships with different controllers based on game mode or player choice. Perfect. So there we go. Now, this diagram isn't wasted, which is good, right? So now that means what I can do is I can say at the top here for the mining vessel, sorry, this is the player controller, and it's not the type player, it should be of type player controller, right? But what it can do is in the ready function, we can get the parent of this component and add it to the group player, right? If there is a parent. So if parent, so we say, we make a variable called parent, and then we say get parent. And if the parent is not null, then add that parent to the player group. And what's even cooler is we can check if it's a valid player object, right? So you can't, for example, make an asteroid or a waypoint the player. I mean, you could, it would be if we don't do this check and say we make an array of players, right? So defender ship, miner ship, and pirate ship. If we don't add that and say if the parent is in one of these types, what would happen is you could make literally anything become the player. And I mean, that might be a cool trick. It might be a nice little feature. You know, you can make anything into the player. Maybe you can make it like a cheat at the end. You know, when you beat the game and then you unlock cheats, then you can make cheats and say, oh, okay, now the player can play as anything. Can play as a waypoint. He can play as an asteroid. He can play as a capital ship. That would be really cool. He could even play as an omni light, like a point light that flies around as a point light. Oh, that's amazing. For now, though, I'm jumping around. I'm getting too focused on details that are sparsely connected. I'm trying my best not to do that. I need to be focused on one thing at a time. And but at the same time, I'm also trying not to lose these ideas. And I need to have a notepad open for these live streams so that I can write these down and not forget them, because they're such good ideas. Anyway, maybe we could make comments. Controls hint label. So what is the play controller script added to? Do I have a scene for this? If I go into scenes and say entities, I've got the player scene. So let me open the player scene. The player scene. Oh, so I did do this. That's so cool. I did it. Look, here. Player controller. So there, we've got the player controller, and it takes in, does it take in a resource at the top? It doesn't, does it? It should take in a resource for the ship type. Oh, no, it shouldn't. It shouldn't. All it should do is set the collision shape to be its parent. The parent's collision shape. So it should set this collision shape to be the same as its parent's collision shape if there is in fact a parent. Okay. Now we are getting somewhere. We're getting somewhere. Okay. Okay. So the mining vessel should have not a player controller script. It should have a mining vessel script. And the mining player should have NPC behavior, NPC this, NPC that. Okay, let's check in the scripts. Do I have behaviors for components? Behaviors for controllers, behaviors for steering, players, enemy AI, NPC behavior manager, enemy ship behavior, player, mining player behavior. So they should be, this should change to NPC AI. We'll rename that to be NPC AI. And then we can have, we can have a pirate ship behavior. We can have a pirate ship behavior, a defender ship behavior, and a mining ship behavior, mining vessel behavior, right? Pirate vessel behavior, defender vessel behavior, mining vessel behavior, and each of these has the possibility of getting the player controller attached to it. So that's the next whole system we need to develop. So I hope you appreciate how powerful this is, right? That I'm not just doing this for the sake of creating content or for the sake of dragging things out so I have more live streams to do, right? This is in fact fundamental to progress. And that's why it's a foundational thing. It's a fundamental step. And if we have this in place, the rest of the game is basically just done. It's just a matter of implementing levels or designing patterns, behavior patterns and stuff. That's all that's left after this, right? So if we get this right, most of the game is done. Like 80% of the game will be done, right? Because then we'll have all three modes. We'll have all three game modes ready and waiting. We just have to implement the rest of it, right? So we'll have the skeleton of the game, and then we can just flesh it out, right? So we've got we just have to create a menu for player selection, so the player can select a level and choose if they're choosing testing seek behavior or what's it called, firing range. If they choose those scenes, it should open up a child menu before that, just a quick menu to say which ship. Do you want to play as a pirate? Do you want to play as a defender? Do you want to play as a miner? And once they choose that, then we can select, or rather add the player controller to the neutral ship, and it becomes a player instead of an NPC. All right, and then it's got the player controller and it's a miner, and so then it shouldn't be able to fire projectiles. It should only be able to mine. It shouldn't be able to hurt ordinary targets. It should only be able to hurt mining objects, and so on. And if we choose the pirate, it shouldn't be able to mine anything, but it should be able to hold cargo and all of these cool things, right? So we could add all of this stuff. So I think the primary offering in my live streams that I'm offering you guys, that I'm giving you guys, is less about actual like coding and things, and more in the sense like game design and development simultaneously, right? Because a game designer will design everything on paper and not really care too much about the underlying details. It'll be like a high level declaration, right? So there's, as an aside, there are two paradigms in programming. Okay, so there's declarative programming and there's imperative programming. Okay, so imperative programming is the type of programming that most people are used to. Okay, so you say, do this, then this, then this, then this, and then that, right? In this sequence, exactly like that. Okay, and declarative programming is more like this. This is declarative programming, a layered architecture system or an indirect system like this, where you do function calls, okay, or signals. And you say enemy ship controller calls a pattern. It doesn't care how the pattern is done, as long as the pattern gets done, okay? The separation of concerns and stuff. It's like, I want the pattern done. I don't care how the pattern gets done. I just care that the pattern gets done. That's not my problem. You, behavior manager, you decide how it gets done, and then tell me when it's done. And then the NPC behavior manager goes, okay, cool. In order to get the pattern done, we first need to seek the target, then we need to shoot the target, and then we need to fly away from the target. So let's call those 3 behaviors, right? So first the seek. Do the seek, let me know when you're done. Then it seeks. It lets it know when it's done. And then it goes, okay, and now you need to shoot. Let me know when you're done. And then it shoots, and it lets it know when it's done. And it's like, okay, now you need to fly away. And so it starts flying away, and it lets the behavior manager know that it's done. And now the behavior manager knows that its role in the pattern is done. It lets the enemy ship controller know that its role in the pattern is done. And the enemy ship controller goes, perfect, here's the next pattern, and so on. Okay, so that is a declarative system, whereas the imperative system would be, what does the behavior itself do, right? So inside the seek function, the steps inside the seek function is imperative. So you see the difference, okay? And I was saying there's a difference between imperative and declarative, right? So the game designer in the industry is more of a declarative design, right? And a declarative architect. He or she doesn't necessarily know how to achieve the functionality they want, but they know they want that functionality, okay? So as a game designer, I would say the player should be able to choose between a defender, a miner, or a pirate. And if they choose these roles, if they choose one of these roles, they should be able to do some things that the other roles can't do, and they should be able to do some things that any role can do, and they shouldn't be able to do some roles that the other roles could do. Okay? And so on. So you see how this design is programming independent. It's independent of the programming system. So it doesn't matter if this was an Unreal Engine project or a Unity project or a Godot Engine project or an O3DE project or any other game engine. It doesn't matter. It doesn't matter if it was written in pure C++ without a game engine. It doesn't matter. The point is, once the game is running and finished and final and published, these features need to be present. How is it going to be done? That's not my problem. That's the problem of the game developer, right? The actual programmer, the guy who sits down and implements all these mechanics. So my offering is a hybrid. It's a combination of two, right? I am designing and developing, and I'm giving you this view of how to bridge the two, right? You need to have an understanding of the programming and coding side of things, right? Remember, there's a difference between programming and coding. I'm not going to get into that because that's going to take a while to explain again, right? But there's a difference, right? The one is the architecture and the other one is the construction. Okay, programming is architecture, coding is construction, as a very brief explanation of the difference. And then you've got that side of things, which is development, and you've got the design side of things, which is what is the actual vision for the game, right? What are the features you want present, and how is the game actually going to work? You know, so in terms of the rule sets, the win and lose conditions, what kind of features the player will be able to enjoy, you know, if there's a difficulty setting, how are those changes going to happen, right? So what is the difference between easy, medium, hard, and nightmare, you know, and all of those kind of stuff. And that's the design side of things. So that's the declarative side. And the imperative side is the developer. Okay? Now, we've kind of run out of time. And to be honest, I was doing a little bit of this explanation on purpose to take up the rest of the time, because I didn't want to get stuck halfway on something and then run out of time and then have to pick up where we left off, and you don't remember and I don't remember and we get stuck. And I'd rather just start clean in the next live stream. So I thought I'd offer you this set of explanations as additional value, as enrichment. So hopefully you appreciate that, and I appreciate your staying with me until the end of the lesson. Sorry, not lesson, session. I mean, it is kind of a lesson, but not really. It's more of a live stream session, which kind of meshes together to make lesson, but no, it's a live stream session. Anyway, thank you so much for your attention and for your time. And to you, Cubes, thank you so much for your support. He's our junior DevVenturer, a member on my Coffee page. And if you want to support the channel, please do visit coffee.com/mtkdev. It's over here at the bottom of the screen, and there's a link in the description. Please do also check out the Discord server. The link is in the description too. You're very welcome to join the community, and I hope to see you there. And also